The regulations on the construction and inspection of small cargo ships specify the requirements for stability documentation that every vessel must be equipped with. You need to have stability information that gives you quick and easy guidance on the ship's trim and stability and restrictions under all loading conditions. Now, these conditions are stability data are not always that easy to understand. Put it very mildly. Some of them are very difficult. And understanding all the information in a vessel stability data for any vessel requires engineer level competence, which we do not have. We are going to look in the next part of the course through some examples of stability data and have a look at the aspects that are the most relevant for us when our purpose is to know what kind of operational limits do we need to adhere to for our vessel. The aim, to understand the vessel stability limitations sufficiently well to avoid overloading and stability related accidents with the vessel. We do not want to do this. The stability vessel data of a vessel will contain loading conditions that cover the ship's operation. This means typical loading conditions with weights on board, distribution of weights on board, where you have calculated GM values, GZ curves, etc. How many loading conditions you have for a particular vessel will vary, but you must at least have a light ship condition, which is completely empty, no cargo, no fuel, nothing. A departure ballast condition, which is 100% of fuel and water but no cargo. Then you have arrival ballast, which is typically 10% fuel and water but no cargo. You have a departure condition fully laden with 100% fuel and water. You have arrival loaded, fully loaded with 10% fuel and water. Now, if the vessel is approved for crane use or towing or anchor handling, any limitations on the use of cranes should be specified for each individual conditions. And you may have many more conditions than just the minimum requirements here. You need to have conditions that cover the vessel's operations. As a captain, you can compare your actual loading condition at the moment with the calculated condition that it most closely resembles, and then you can have a good idea about your stability, what kind of safety margins you have, and whether there are any operational limits with which you must comply. And for some vessels, there are limits. Now, there are many similarities between stability data for different designers, from different designers and manufacturers, but there are also differences. In addition to a stability book, every vessel must have a stability poster in the chart house that has information about the vessel's limitations displayed in the chart house. And depending on what is relevant for the ship, the stability poster must at least contain information on the type and quantities of cargo that can be put on holds, tanks, and in decks, pursuant to section 30 and 32 in the regulations. It must have information on the use of ballast, any restrictions on the use of roll damping tanks, and the ship's capacities and limitations with regards to towing, anchor handling, and the use of cranes. As a captain, it is at all times your responsibility to ensure that the vessel's stability is adequate and that all stability requirements are fulfilled. To be able to do this, to make sure that this is the case, you need to be able to use stability data to answer the following questions about your loading condition for your vessel at any time. What is the size of my GM, and particularly, is it larger or smaller than in other loading conditions? What is the range and extent of my GZ curve? How much freeboard do I have? It should always be more than 200 millimeters. Are there any operational restrictions relating to operations that I need to take into account? And we see here a diagram with restrictions on the use of crane. Now, these questions are of course interrelated, and by asking yourself these questions in a systematic and continuous way, you should at all times be able to have a clear understanding of the extent of your safety margins with regards to stability, and make sure that you at no point enter into operations where your stability margins of safety may be compromised. Now, in the continuation of the course, we're going to find answers for the questions mentioned above in the stability data of different vessels.